Welcome to AP Biology. Today I want to go over the Hardy-Weinberg practice problems that we've been working on in class because a lot of kids kind of struggle with this stuff. So the first question is about sickle cell anemia, and if you read through it, the important part comes in at the bottom. So it says that 9% of a population has little s, and then they want to know what part of the population will be heterozygous. So if you read through everything, that's actually what they're looking for. So I always start by writing down my knowns. Because sometimes these problems can be a little bit intimidating. So as long as you go step by step, you should be okay. You'll at least get it started. So 9% is little s. And then it wants to know, these would be your unknowns, right? It wants to know what your big S little s is. So if 9% is little s, that's little s is Q squared. Why is it not Q? So Q is the recessive alleles, but this person has 2 alleles. So that's not Q, that's Q squared, right? So Q squared is 0.09 because your number has to be 1 or smaller. So this is all done in not in percentages, but down into some frequency, which is going to be a number smaller than 1. So if Q squared is 0.09, I don't know, I've got a couple formulas, right? P plus Q equals 1. I can't do anything with that because I don't know these. I know that P squared from my formula sheet plus 2PQ plus Q squared equals 1. So I have this, but I don't have P squared and I don't have Q by itself. So anyway, all I can do right now, first of all, is take the square root of both of these. So that's what I'm going to do. So that means I'll get Q. So Q equals 0.09. The square root of that is 0.3. And now I can use this formula to figure out P. So P plus Q is 1. So that means P is 0.7 in this case. And so now I know what P is and what Q are. So those are my allele frequencies. So later I'll be asking you for that in other problems. But your allele frequency is just a frequency of like your little s or your big S, right? Here's the little s, here's the big S. But that's not what you'll see in any particular person because people have 2 alleles, right? Either 2 of the Qs or 2 of the Ps or 1 of each. So it wants to know heterozygous. So the heterozygous is 2PQ. It's this part of the formula. So that's 2 times P, which is 0.7, times Q, which is 0.3. And if you multiply that stuff out, you get 0.42. And I can leave it like that, or I think it says the percentage, so I'll change it to a percentage. So I'll say 42% are big S, little s. And that is my answer for the first one. Okay, the second one says, within a population of butterflies, the color big B is dominant. So I'm going to say big B is, let's see, brown. And by writing it as big B, I'm saying that one is the dominant one. And I'm going to say little b is white, and that's the recessive one in this case. And 40% of the butterflies are white, so 40% are white. Okay, so white would be little b, which is Q squared. It's not Q because Q would be one of the alleles, right? Whether it's in homozygous, recessive, or heterozygous. So Q squared is 0.4. Given this simple information, calculate the following. So first of all, so this, by the way, right, these are sort of my knowns. So if I'm looking at part A, the percentage of butterflies that are heterozygous. So I want to know big B, little b, what does that equal to? So that's 2PQ. And so that's 2 times, I don't have P or Q. So let's come back to this. What can I do with that information? I can take the square root. So the square root of 0.4 is going to be 0.63. And if that's Q, I also know that P plus Q is 1. So P is going to be 1 minus that, right? So it's going to be P equaling 0.37. These are my allele frequencies, which is not what it's asking for right now, but I've got it. Anyway, they want to know heterozygous, so it's 2 times P, which is 0.37, and then Q, which is 0.63. That's a 0.37. Okay, so I've got 2 times 0.37 times 0.63, and that equals 0.47. Right, so anyway, does it ask for percentage? The percentage, yep, so I'm going to say 47% are big B, little b, so that's part A. I got 0.46 on my other one. Let me try that again. 2 times 0.37 times 0.63. Yeah, I have 47%. Okay, cool. Okay, part B, it says the frequency of the homozygous dominant. So homozygous dominant is big B, which is really P squared. So I already know that P is 0.37, so that's just 0.37 squared, right? So 0.37 squared is 0.14. And I don't think they asked for percentage, so I can actually just leave it here if I want to for part B. All right. It's not a bad idea to double check all of this stuff. So if I add like 14% plus 47 plus 40, let's see if I get 100. So 14% are dominant, plus 47% are heterozygous, plus 40% are homozygous recessive. I get 101, which is pretty close to 100. Okay, part 3. A very large population of randomly mating laboratory mice contained 35% white. So what do I know? 35% are white. I don't know if white is dominant or recessive yet. Let's see. White coloring is caused by the double recessive genotype, little a, little a. So that means you have two parents, right? So that's a Q squared, not a Q. So Q squared is 0.35. Calculate the allelic frequencies and the genotypic frequencies in this population. Complete dominance just means that like little a would be white and big A would be whatever the color is, brown or whatever. Okay, so if Q squared is 0.35, I can figure out Q by just taking the square root of both sides. So 0.35, the square root of that is 0.59. And then I know P because P plus Q is 1, so that means P is 0.41. Okay, so this is actually one of the first things that it asks for, the allele frequency. Allelic frequency, the frequency of the recessive allele and the frequency of the dominant allele. So you can see that the recessive allele is actually more common. So then it wants the genotypic frequencies, which means I need big A, big A, big A, little a, and little a, little a. So big A is going to be P squared, which is 0.41 squared. So 0.41, whoops, 0.41 squared is 0.17, or 17%. Big A, little a is 2PQ, which is 2 times 0.41 times 0.59. So 2 times 0.41 times 0.59 is going to be 0.48. That's the frequency. If you want it in percentage, it's 48%. And then a, little a, well, I already actually have that. They gave that to me in the beginning. That's this one. So that's 35% or 0.35. So if I add these, I'm hoping it adds up to 100. So 35 plus 48 plus 17, that gives me 100%. Hip, hip. These are my genotypic frequencies. So notice that the recessive allele is more common, but actually the recessive coloration is less common, right? If you add these two together, you get more of the like the darker color, not the white, right? This one's white. The others are some other color. And that's because a lot of them are heterozygous and the dominant one is actually what you end up looking like. So that's kind of cool.